let's quickly summarize what we have achieved so far, and also what we will create in this chapter. In the previous video, we have created a temporary UV map to guide the projection modifier in order to bake the current maps on your screen. We have created complete map, normal map, and specular map. Inside Photoshop, we have edited and corrected any deformation in these maps, and also, we have added a background color for each. After that, we have rendered a template for the final UV map of the first level of detail, rim. In this chapter, we will create these new maps for the lower level of detail. Generally speaking, these are the most commonly used textures, or maps, that you need to create for the rim. However, there are also other maps that you need to put into consideration, such as maps or textures, which are commonly used to mimic environmental changes or effects. For instance, this dirt map is one of the environmental effects that will be applied to the rim during the play time. You can create a custom dirt map for each vehicle rim. However, most of the time, the game engine utilize common textures that can be applied over multiple assets. This technique is used to save both time and effort, also to improve performance. In this tutorial, we will use this common dirt map for the current rim, and we need to make sure that the UV map is perfectly wrapped to make the environmental effects more believable. Without any further delay, let's dive into it. Let's pick up from where we left off in the previous tutorial. Here is the brief. The last baking was not quite satisfying, or closer to the game standards that we discussed early. I am going to show you another technique to create high-resolution textures inside 3ds Max and minimize the editing time inside Photoshop or any other image editing software. We need a surface to capture the high-resolution details. At the same time, it should cover the high-resolution mesh. That surface does not necessarily need to be similar to the high-resolution surface. It could be, for instance, a plane that covers the main details we need to capture on the projected maps. In the left viewport, create a plane with equal length and width. Align the plane with the rim, then move it until it covers the side details. You should leave few extra millimeters when covering the surface to fully capture the maps. Otherwise, the projected maps may have trimmed edges. Add and wrap UVW modifier over the plane object level. Repack or unwrap the UV map to fit the map dimensions. Convert the plane to editable poly, then add projection modifier. Pick the high-resolution rim and its components from the default layer, then bake the required maps. In this scenario, we do not need to push the cage, and it will not matter. Press 0 on your keyboard to open the Project to Texture utility. Pick the high-resolution rim and its components, again, from the Render to Texture utility. In order to balance the light and the shadows effect upon the rendered texture, add a standard Omni light, with 70% intensity, at 2-meter distance, from the rim left side. We can increase the size of the baked texture, then use the rendered texture to correct any deformation in the L0 texture that we have baked in the previous tutorial. Let's check the baked texture inside Photoshop. Clearly, the baked texture has trimmed edges. We should make the plane surface larger than the rim. We could spend some time and correct these edges inside Photoshop, but this is not the right approach. To save our time, I did the bake again, off camera, and these are the new maps. If you notice, some of these maps are not named correctly. Although, this will not affect the baked material, because 3ds Max will wire each map to its correct slot, regardless to its name. However, we need to keep everything organized. I will correct these names later. Scale the baked texture to fill the map size. Save the edited maps to the project folder with proper names. In this part, I will show you how to use the texture we baked to correct the L0 texture that we have baked in the previous tutorial. In some cases, you may have a texture, but you do not have access to the 3D model, and you still need to create other maps. Nvidia has a plugin called Nvidia Texture Tools for Photoshop that can help you to generate normal maps. With the help of this plugin and other Photoshop tools, you can generate different maps if you are willing to put some effort and time to create them. You can adjust the map size inside Photoshop. I do recommend to keep all map size as shown early at the beginning of this tutorial. I already imported the maps to the project folder, then wired each one of them to the baked material. You can change the baked material name to any name. However, it's better to use the same name as the wired diffuse map. Now, we need to assign this baked material to each lower level rim, except L4 and L5, we will create another material for them. We will correct the UV map to match the texture, then we will do further editing inside Photoshop to correct the shadows around the bolts and other areas. Add and wrap UVW modifier to the L1 rim object level. Switch the checker pattern to the rim texture. Again, the improper maps names will be corrected later. The current selection has a cylindrical shape. Thus, I am going to use the cylindrical projection to wrap this part. Use the cylindrical projection on X-axis to wrap the selected UVs. Break, then overlap similar UVs. This technique is used to shrink the required area for the UVs on the map, especially for those areas that do not contain important details. we can dedicate any empty portion of the map to colorize the selected UVs with a special color. This is the main reason I picked darker gray color for the background. The inside part of the rim should have a darker color rather than the side part color, which is exposed to lights. And this will make your model more believable. We shall organize this UV map further after completing the wrapping and the packing process for the final UV map. You need to visual inspect the 3D model for any texturing distortion, such as the darker lines at the rim pillars, inner edges. We can fix this by editing the UV map. However, this is a texture problem, and the right decision, in this case, is to edit the texture itself. Our texture also have a lighter color in cavity areas, such as the bolts attachment holes, which definitely looks unbelievable. We need to give these areas a darker color in order to fake depth. We need to have the original bake map for this editing. Hold the Control button, then left mouse click on the map layer to select the whole texture. Contract the selection to exclude the dark edges of the texture. Ctrl-Shift-I to invert the selection. We need only to delete the inside portion of the texture, not the outside. However, there is no easy way to do this. Duplicate the texture, then delete the selection. Hold Shift while using the elliptical marquee tool to create a circle selection smaller than the original texture. Then, align the selection to the center of the texture and hit Delete. Make sure that you are on the first layer, not the duplicated. Add a background color layer and move it to the bottom. On the upper layer, press Ctrl-E to merge the upper layer and the layer below it. Scale the texture to match the map size. To correct the shadows around the bolts, use the brush tool to draw a dark color to mimic shadows or depth. I do recommend using a graphic pen for heavy drawing or patterning. We can continue repeating the same pattern for each hole. We could simply avoid the headache if we did not bake the bottom of these holes from the beginning. However, with challenges come the opportunities. Let's demonstrate precision inside Photoshop. I am going to use the equal diagonal distribution of cloned objects technique, meaning rotate and equal distribute the cloned objects around the center of the map with a constant angle of rotation. Clone the created pattern, then cross horizontal and vertical guides at the center of the map. Ctrl-T to activate the free transform. Press Ctrl, then move the reference point with the left mouse to the center of the map. In the reference point settings, set the horizontal and the vertical values with the half value of each map side, respectively. The map size we are working on is 2K or 2048 by 2048 pixel. Type 72 in the rotate value to rotate the cloned object 72° clockwise to cover the next hole. After editing, resize the map and save it to the project folder. In this part, I am going to correct the L0 rim UV map. We need to correct the bolts holes color. This area should have a dark color to mimic shadows. We could edit the texture inside Photoshop by drawing a dark pattern to mimic shadows over these areas. However, the best solution is to wrap these UVs to a darker portion over the map. I will do the same for the bolt sides. During the visual inspection, I noticed some texture deformation on the L1 rim. Let's fix them inside Photoshop. We can render a UVW template and use it as guide during the texture editing process. duplicate, and rotate the created pattern with the same technique we used earlier. Time to scatter some sugar on this bake. In the introduction of this tutorial, we have mentioned the environmental effects, such as the dirt map, that we need to put into our consideration during the wrapping process of the final UV map. We need to adjust the UV map of the rims to match this dirt map. First, we need to wire the dirt map to the baked material. We can replace the diffuse map with it temporarily. Or, we could use a mix node to render two textures over the same surface at the same time and mimic the game engine shader. Before diving into the mix node settings, let's take a look at the 3D object. Obviously, we need to wrap the UV map to render the dirt map in more realistic and believable way. In reality, the pillar's inner sides, the cylindrical sides of the rim, and the tire mounting area should not have any dirt over their surface. We need also to fix the texture distortion over the cylindrical sides. I strongly recommend to do this wrapping process over the dirt map or the texture that you will use inside your game engine. You can use a noise node instead of the dirt texture to adjust the UV map. However, the result might not be accurate when replacing the noise texture with the game engine dirt texture. The following is just an introduction to the materials and the nodes inside 3ds Max. We may uncover that later in a dedicated tutorial. Double-click on the Mix node to open the material options. The Mix node function is to combine and average two maps or textures. The mix value will determine the amount of this average. The maximum value for the mix amount is 100. When using low values, you cannot actually see any change or mix. Let's explore the wiring options first. You can swap the texture's order, and this will change the mix result. We will uncover this in details later in this tutorial. For now, let's wire the dirt map to the mix value and proceed into our main objective. Wiring the dirt map to the mix value has rendered the mix result inside the viewport. However, changing the 3D object material while working on the Unwrap UVW modifier may not render the material changes into the UVW editor. In such cases, collapsing the current Unwrap UVW modifier and adding a new one might fix this bug. In this part, I am going to wrap the L0 Rim UV map upon the dirt map. After wiring the mix node to the material, add Unwrap UVW modifier to the 3D object. Now, we can see the mix node result inside the UVW editor. we need to correct these UVs in order to render the dirt map correctly. These UVs were projected on a planar projection. We could use the cylindrical projection to wrap them. However, the stretch effect of the texture that you may notice on the bold sides is actually realistic, and we need to keep it that way. Let's render the final UVW template for this rim. When you start adding more materials and maps to your project, you will need to organize those materials to ease the visual recalling. Unfortunately, grouping nodes in the State Material Editor is not yet available in 3ds Max, even with the newest version. When deleting materials or maps from the State Material Editor viewport, if those materials or maps are not assigned to any object, they will be gone for good. It is always a good idea to keep only the active materials that you need in the viewport and delete the inactive. This will not delete the materials already assigned to any object. You can recall them any time by pick material from object or from the left side menu of the material editor. Now, let's try to explain what's going on inside the mix node. I am going to wire the mix node to the L0 rim material so that we can monitor the different settings on 3D object. We need to know exactly what the mix node result looks like without wiring any maps to its color slots. We have black in color 1 and white in color 2, and the result is black when using 0 as a mix amount. The result will change when swapping the colors. If we gradually increase the value of the mix amount, we will start to see black added to the white until we reach 100%. The result will be full black. So, this is mean the mix value is actually controlling color 2, and the value determine how much of that color will be added to color 1. This concept will not change if we swap black and white. The mix node will always consider color 1 and anything wired to it as the base color. This is the right order of wiring maps to the mix node. We need to wire the diffuse map to color 1 and wire the dirt map to color 2. Afterwards, we can change the mix amount value until we start to see dirt added to the diffuse map. The same technique is used inside the game engine in order to render shaders or mixed maps upon the 3D object. Now, when adding Unwrap UVW modifier to the mesh, you will see the mix result when switching to the mix node material. When wiring the dirt map to the mix amount, the mix amount value will be automatically disabled, and the mix node will average color 2 by the wired dirt map. Then, it will blend the result to color 1, or the base color. In case you want to compare, here is the mix result when using the right order of wiring maps to the mix node. The mix node color slots is not empty by default. While you can change the color of the slot, there is no option to clear or empty the color slots. The checkbox beside each slots and the mix amount is used to control the wired map visibility. You can disable any wired map by unchecking its checkbox, and it does not affect the color slots. When using the mix node, you need to wire the maps in the right order to get correct result. If you wire the base map to color 2 slot, the mix node will average color 2 map with the mix amount value, or map. Then it will blend the result over color 1 slot. Either it contains wired map or color.